Show of hands, everyone. Who's used CrunchBase? And who's edited CrunchBase? Who's put their name or their company's name on there? One, a few of you. All right. So, out of this crowd, a lot of you have actually used CrunchBase, and that's part of what makes CrunchBase a little bit different than a lot of these other things. Is we also have a lot of user input that goes into CrunchBase. And so what CrunchBase is, is we're crowdsourced. We also have the NLP aspects that I'll be showing you about. And we also have data, and our data is used by a lot of different people. We're used by Mattermark, we're used by DataFox, we're used by different academic papers. And in all these things, we're transparent. Anyone can go to CrunchBase and use our data. And we have a lot of entities in CrunchBase, as you can see. We have many, people, we have companies, we have investments in different startups, and we have, a lot of different users that are actually using CrunchBase. And so this is sort of the basic entity page in CrunchBase. So this is the entity page for Apple. You can see that we have the description, we have information about people who've worked at Apple, and we also have the website. We have so many people, so many organizations, and so many products. Now, there's also the news. And every day there's a lot of news articles that come out about each of these companies, each of these people, and each of these entities that's in CrunchBase. And so what we're trying to do is we want to be able to take these news articles and put them into the CrunchBase entity pages, and then we're able to gather more information about the different entities that we cover on CrunchBase. And so basically what we've traditionally been doing is we have a teams in India and locally that go through the stuff. We also have people in the crowd who are editing CrunchBase entities themselves. And so we have a lot of data that's already come onto the site, but there's a ton of news articles that come out every day, as you can see. And we want to add all these news articles to the news section on CrunchBase. So we designed algorithms to add all these news articles to the news section on CrunchBase to figure out, which entities they're talking about, and which persons they're talking about, and to disambiguate these things. So to do that, we sort of came up with a high-level architecture that involves basically we scrape the web, then we put that into a news database, and then we parse all the stuff, and then we go to the production database. Now, the thing that we have to keep in mind is we want to parse out millions of articles, and we have a very large number of entities that we're trying to identify in these news articles. And so we had to design some infrastructure to handle that and to sort of mesh with our existing data. So we obtained the news actually about 100,000 articles per week. We have our bot that's scraping all sorts of different sources, and looking for the latest news articles that are in all the sort of tech publications, and we're adding more. And then once we get the news articles, we have to scrape the news articles to get out the content in them that's sort of the main body of the text, and find which part of the text the article contains the body of the article from the raw data. And so basically, we didn't really, put the most complicated system in place for doing it. We were able to really get away with a pretty simple system. And what this really shows is that a lot of NLP is not necessarily having the most sophisticated algorithms, but is also having the data available that identifies which entities are which. And so basically, I just use a prior speech tagger, and we identify the proper nouns in the articles, and then basically those get run through CrunchBase. And we also look for companies and things that are not already in CrunchBase for our teams to add. when we run the things through CrunchBase, this is a chart that shows sort of the candidate entities of what we find. So basically what we're doing is we're looking at the different strings in the different articles, and we're trying to see how many of those strings show up in different, are actually CrunchBase entities. So, you know, we look through basically the articles, and then we run each proper noun, basically just do like a text search through CrunchBase, and we say, you know, is this Apple? Does this show up? You know, we also look for, some companies' names are a lot more ambiguous. If you have a company like Drop, that might, you know, be, that could potentially be the word drop or the drop, and some of the company names are a bit ambiguous. And so basically, to develop our algorithm, it's sort of been an iterative process where we just sort of matched sort of the direct matches of the entities. And then later on, we looked at, you know, trying to match less direct matches on the entity strings. And the reason for doing this is we were able to, instead of having to tag the full articles, we were able to just tag the stuff that was matched with the candidate entities. So basically, we have Cisco, so initially Cisco might ever match just whatever we had labeled as Cisco in CrunchBase. So if you're not familiar, there's multiple companies named Cisco. There's Cisco Systems, there's Cisco Investments, there's also various people with the last name of Cisco. And so we had multiple people, you know, in CrunchBase, but, you know, basically initially we just sort of tried to do the direct matches, and then we'd sort of tag and see whether that was the correct one. And so then we were able to tag less training data. Later on, we sort of expanded that, and we were able to, you know, train more data as the project progressed. But it allowed sort of an early prototyping stage without having to necessarily train as much data. And, you know, part of it also with the matching of the names was looking for aliases. Now, CrunchBase has had some sort of aliases actually in the entities of CrunchBase for a long time. But one of the things that we're able to do that, you know, not necessarily everyone is able to do is we can actually, you know, have people manually go through and edit our data and update our data. And when we updated the aliases in CrunchBase ourselves, you know, we have a content team that's able to look at different news articles and different sources, and then, you know, they're able to gradually sort of keep the data, they keep the data up to date. And so then, you know, the higher quality sort of our initial data is, the easier it is when we apply the algorithms to determine, you know, which entity matches which other entity. And so one project that was particularly, you know, helpful with this was basically trying to, you know, clean up our aliases. And so, you know, here's just a simple alias for Google Mail, which, you know, for Gmail basically. And so, you know, having that alias correct means that, you know, we can just match that string instead of having to necessarily come up with a, you know, more complex algorithm to figure out that that string is referring to the same entity as Google Mail in the article. And so some of the difficulties in this was that our data is not just editable by our staff, but anyone can go to CrunchBase and edit any entity, basically. And we do have moderation processes and such, but people make, you know, often make mistakes in how they edited entities. So one of the problems that we dealt with was for aliases, a lot of people would sort of confuse the alias field with the location, and so they put in names like San Francisco, California, or United States, or even Dayton, Ohio. And then when, you know, we went to go match those entities, we'd realize that those entities, you know, some article would mention San Francisco, and then that would get matched against some obscure company that had, you know, just happened to be located in San Francisco. And so there were a lot of sort of errors in the training, you know, in labeling the initial training data that was just based upon the issues of data quality. So, you know, we have two sort of aspects of what we can do when we face these sort of errors. One thing is to go back and clean up our data. Another thing is to try and, you know, make sure the algorithm can handle that. And so it's sort of a combination of the two, of improving the algorithm on the one hand, and then also going back and improving the data quality on the other hand, you know, because we have to sort of keep the algorithm resistant to further changes in the data quality, where even if we clean up the data at the moment, somebody might come back in the future and then they'll edit that entry again, and then the data will be further corrupted again. And so we want, our algorithm's continuously running, parsing out the news articles, and we're running on the latest and greatest of data that's in our system. And so we need to make sure that the algorithm is capable of we're running on that latest data, and that the latest data is going to give us an accurate recognition of the particular entity. Now, when we decided to recognize entities in articles, we really looked at the two things, presence and relevancy. And the reason for this is a lot of articles can have a particular entity mentioned that may not necessarily be what the article is about. And for our purposes, like a lot of articles mentioned iPad, iPhone, Apple. If you look at the business and tech news, just about every company that's coming out with an iPhone app is going to mention, iPhone. Although iPhone is not necessarily for a CrunchBase entity page for iPhone, we don't necessarily want to mention every iPhone article that mentions just some iPhone app, because that may not really be significant to Apple. That's not really saying that Apple's improving their iPhone or doing something new to the iPhone. It's just saying that there's a new iPhone app. There's other cases, if you look at articles where there's basically just something mentioned as an aside in the article. So basically, to make the training process easier, we really split it up into the two criteria of presence and relevancy. So the presence is just saying, is this present in the article, no matter in whatever form it is, and then relevancy is sort of a more complex criteria that was sort of more difficult to determine. And the reason this is useful also for a training purposes, because the presence is a lot easier sort of to determine based off of the data when you're training it, because when we obtain the training data, basically, we just have sort of a Google spreadsheet where we had people label different things. And so if you're going to try and determine if the thing is relevant to the article, that's a very sort of high cognitive task. Looking at through the article and saying, is this entity actually in the article? You just look for Google and you say, is this talking about Google, the company? More complex entities is there's a startup called, say, Friday that does something or other, but every time that the word Friday is used in an article, it's not going to refer to the startup Friday most likely. And so those type of things can get disambiguated out with the presence, but not the relevancy. So here's sort of just a sense of like how we labeled the data for various articles. So if you look at the spreadsheet, this is just a Google Docs spreadsheet. So this is sort of what we actually used for labeling the training data. So you can see that Apple is both relevant and present in the particular article this is referring to. And Bluetooth is mentioned in the article as present, but it's not really relevant to the topic of the article. I think the article mentions that Bluetooth is used in the iPhone or one of the devices in the article. And so, you can sort of see this. And so we're able to sort of try and disambiguate this down. At the bottom, you can see a lot of different place names. Locations are actually a bit tricky because there's a lot of like obscure towns around the world that have names that are very similar to a lot of different companies' names. You see Marvel, Arkansas, and that's there's a company Marvel, which is probably what that's referring to, but the little town gets picked up. And so we were able to sort of filter out most of those because there wasn't a lot of entities associated with those towns, and so we were sort of able to eliminate that. But sort of from a pure matching perspective, we sort of had to see what that was. And we tried some methods of disambiguating the company names and the product names, although that wasn't necessarily all that effective for what we did. So the features that we used for identifying entities, a lot of the stuff was based off of the graph. And so basically the way that CrunchBase works is we have a graph that shows the connections between all of the entities, and we actually use a graph database. And so for features, we were able to look at the first degree connections between entities, which was like a single hop in the graph, second degree connections, which is 2 hops, and sort of different ways of sort of looking at the measures of the connections between the entities. And that proved to be a very useful feature in looking at, which ones. We also looked at like the total number of entities that were matched for like connected for a given entity. And, that sort of tells us if that entity is a popular entity that's important in CrunchBase or that's an obscure startup. Now, doing those types of features are a bit tricky because new companies get added to CrunchBase all the time, and so those features may not be in existence yet because maybe we don't necessarily have full data on each of the companies that's added to the CrunchBase. And so for those, there may be less data, and matching is a lot harder to do. And we also looked, on that note, we looked at more entity-specific features, which were sort of, looking at just we're trying to look at the type of entity in the news articles. We didn't really get that sophisticated. We just used some open source libraries to identify the entity type, but that wasn't necessarily totally indicative because there can be some references in articles that refer to two different entity types sort of in the same text where things get tricky. It could be like Microsoft, Windows. There's names of companies that are also names of people, and it can get tricky in trying to identify those. But that was another feature that sort of helped in the more entity-specific features. The other thing, is obviously just like TF, IDF type frequency features, looking at, which entities show up a lot in news articles and which entities, show up and are actually present in the news articles, using sort of a second pass at the algorithm for that. And so using that, we were sort of able to figure out, have a bunch of features that we were able to apply. And basically the algorithm that was used was basically, just to sort of summarize, you take the proper nouns in the text, we look for, candidate names that match, apply some heuristics, and we determine if the candidates are relevant. And basically, I didn't do anything too fancy. Basically, I actually used the random forest implementation in R, was able to just export it to Ruby, and then run that in Ruby in production, which was sort of fit in with the rest of our production systems. So able to really keep a really very simple implementation that was quite effective. So here's sort of this ROC curve of the entity resolution. So you can see that it's quite accurate model that we tried to keep down keep it accurate, and so this is basically what we used. And some stuff that we found with now isn't necessarily relevant, and the relevancy does sort of vary depending on the type of entities as well, because a company like Apple shows up in the news a ton of times every single day. And some new startup might show up in some reference in some article once, and that new startup is the one news article about that startup is going to be important and significant, just because that's the first time that startup appeared in the news. And so if you're working for that startup, you're going to care. Apple, on the other hand, shows up so often that sort of the relevancy is not just a matter of is it relevant in the article itself, but it's actually a function of how often it appears. And so that sort of metric sort of helped play into trying to determine what was relevant. So just sort of to summarize, we have a lot of different entities in CrunchBase, and we're parsing through a lot of different articles to figure out which articles go onto CrunchBase, and we consider probability, relevance, and frequency. We're combining, manual curation and the community with sort of the automatic natural language processing stuff. So, any questions? Yeah.
It's more significant that if it appears on the news,
Mhm.
can you somehow adjust the factor of relevancy by this novelty aspect?
Yeah, well, I mean, it's just a matter of how many news articles the startup's appeared in before. So if the startup has appeared in 1,000 news articles before, the relevancy score is going to be different than if that's the first appearance in the lifetime of our collecting the data. So that's basically how we adjust for that. Other questions? Yeah? What about the training sets?
So do you have were you able to get lots of positive versus negative examples?
So basically what we did was we looked at the strings that match. So we basically did a look of the proper nouns, and then we did a text search through CrunchBase to see which possible entities would possibly match. And then we just, and so then those were the candidates, and then we'd mark those yes or no. The reason we got a lot of no's, because there's a lot of entities that just have similar names to the ones that were in there, or there's ones that, there's locations that have similar names as well.
So what I meant is that for every single
Yeah.
match, pair that matches, then you have all the candidates as a negative example.
Yeah. I mean, the negative examples would be the ones that match. If the string doesn't match the name, then that's just not considered, basically. If in terms of we're only looking for proper nouns too. If it didn't get tagged as a proper noun properly, that would sort of get excluded, and that wasn't really considered. But the proper noun tagging is pretty good in terms of things. Stuff that doesn't get tagged as proper noun. It happens occasionally, but it's that's pretty strong. If the string was way off or something and different, there may be a few cases where that occurred, but that wasn't too frequent. So, yeah.
So going back to your iPad example, what do you think is the most important feature that tells you that the article is about an iPad app and not Apple? What are all the features? What do you think is
So the most important was the graph features that were basically, if it says Steve Jobs and it says Apple, then we know that Steve Jobs is linked to Apple. And so it's going to be a very strong indication that it's about Apple instead of about, I don't know, some other company named Apple. So that was definitely the strongest feature. There were others that were just, is it an exact match? But in us, also another thing that's not necessarily, I don't necessarily want to say it's the strongest feature, because is just looking at which entities have appeared a lot in the news before. We know that Apple Computer appears a lot, so that's a strong feature in a sense of saying that because it has appeared a lot, it's likely to be there. And those are basically the strongest. Yeah?
I was just wondering, so you're trying to extract knowledge and map that into your entities, but you consider doing the other way, like changing people to actually annotate their articles using your entities directly, so that they tell you, they communicate the intent. Oh, this is about Apple, and this is the entity in the CrunchBase that I want to use, using some kind of user ID or RDF data.
There are people who are actually annotating stuff with CrunchBase entities. They just use the URL typically. Internally we call it the permalink, basically, it'll be just /organization/Apple, or if there's multiple entities that are the same name, then the URL will be slightly different. So that's basically, internally we have a UUID, but most of the time it's easier just to use the permalink. Any other questions? All right.